everybody. Today is Thursday, August 18th, 2016. And this is Before the First Cup of Jules here on UCY.TV. Happy Thursday, everyone. It is a balmy 74 degrees and humid here in upstate New York. Very, very sunny, and I think it's going to be a warm one. So where do we leave off? Yesterday, we titled the show, DARPA, Skynet's Brain Initiative, Bioenhancement, and Sophia. And yeah, we talked about Sophia. Sophia is that humanoid robot that they rolled out last March at that South by Southwest conference in Austin, Texas, who even jokingly, and so they say, when they asked her some questions, she had said that she would like to kill all humans. Well, Sophia's come out now, and they've put her in some interactive situations with humans so she could learn, and now she came out and said she does not want to kill humans anymore. So that's a good thing. Phew! Sophia and humanoid robots aren't out for our skin. They're just going to make us our pets. They're pets just like Elon Musk talked about. We also talked about neural dust and electroceuticals and being able to bio-enhance humans at some point in the future. And we found out the majority of Americans aren't really so sure that they would go for that. We looked at the brain and ways that they can manipulate, ways that they are finding to scan the brain and garner information. And I kind of joked that at some point in the future, they might be able to scan us remotely and be able to tell who we are and what we're thinking. Well, that, I guess, is not such fodder of the future. I dug into that new Li-Fi technology, and that is doing wireless internet connectivity through light bulbs, through LED light bulbs. There was one time I had found a story about them already experimenting with those Li-Fi light bulbs at Newark, New Jersey's airport, Newark International. And I was just trying to find a story on that. You know, how amazingly difficult it is to find something once you've found it before these days. But I will find it because I know it was the Newark airport. But anyway, let's look at Li-Fi for a minute, because some of my postulations apparently weren't too far off. What is Li-Fi? Well, Li-Fi stands for light fidelity, or Li-Fi. It is a visible light communication system running wireless communications at very high speeds. Li-Fi uses common household LED light bulbs to enable data transfer, boasting speeds of up to 224 gigabits per second. That's massive. The term Li-Fi was coined at the University of Edinburgh by Professor Harold Haas during a TED Talk in 2011, and Haas has envisioned light bulbs that could act as wireless routers. Li-Fi and Wi-Fi are similar in both that they transmit data electromagnetically. However, Wi-Fi uses radio waves, where Li-Fi runs on visible light. Now, think about that for a minute. We're sending data over light. I mean, I guess it's like fiber optics. That's pretty much what they do in fiber optics, except this is going to be free in the air, sending wireless data over light beams. As we now know, Li-Fi is visible light communications, and it means that it accommodates a photo detector to receive light signals and signal processing elements to convert the data into streamable content. An LED light bulb is a semiconductor light source, meaning that the constant current of electricity supplied to an LED light bulb can be dipped and dimmed up and down at extremely high speeds without being visible to the human eye. For example, data is fed into an LED light bulb with signal processing technology, and then it sends data embedded in its beam at rapid speeds to the photodetector, which is your photodiode on the other end. And the tiny changes in the rapid dimming of LED light bulbs is then converted by the receiver into an electrical signal. And the signal is then converted back into binary data that we would recognize as web, video, and audio applications that run on internet-enabled devices. So think about that for a minute. So we have now wireless connectivity through light bulbs that they can put anywhere, very ubiquitous. They can be hidden in any place that we have a light bulb. I read at one point they were even experimenting with embedding microphones to be able to pick up audio and send it to wherever it goes to on the other end for public places and surveillance purposes. Well, I had joked yesterday about how long it's going to be since our brain scans are as individualistic as a fingerprint. How long it's going to be before they are using these Li-Fi light bulbs to scan everyone who goes under them and identify who you are and be able to tell whether or not you're having a moment that might make you suspicious. Well, it's not going to be too long in the future. So I found a story yesterday from September 17th, so this must have been from 2015, from a company called Versa Technologies, titled, "They tried to transmit brain scans using Li-Fi LED lights, and guess what? It worked." Li-Fi is a relatively new connection method pioneered by researcher Harold Haas from the University of Edinburgh that can connect users to the internet using LED lights. Well, yes, we've established that already. But researchers from Pukyong National University, and I'm assuming that that is in China, seeks to research and to adapt this new technology for medical usage. Successful Li-Fi implementation in hospital environments will make it possible to eliminate the need for medical devices to rely on wired connections to achieve internet connectivity. Researchers have been able to successfully transmit electroencephalograms, or EEG, brain signals via Li-Fi, and the IEEE spectrum reports that powers ranged from 1/2 to 100 millivolts and frequencies between 1/2 and 45 hertz. RGB sensors were then used to amplify the weak signals and to filter out the distortions. And the research team has also been able to obtain electrocardiograms, which are EKG readings. And think about this, so they can get your brain scans and they can get your heart readings passing underneath a Li-Fi light bulb. How long is it going to be where they're not only figuring out who you are by your brain imprint, because we know brain imprints are as individualistic as a fingerprint, but they also could tell whether or not you're having a moment where, you know, you might be planning something because your heart rate is accelerating. EKG is a medical device that reports the electrical activities of the heart. Li-Fi could also potentially support electrocoolography, which is an EOG, a technique that measures the distance between the front and the back end of the eye. Not sure what they'd use that for, but I'm sure if I dug into it, we could find some science that goes along with it in the brain. Li-Fi, short for light fidelity, avoids crowded RF spectrums, and it can transmit information way faster than Wi-Fi. Gizmag magazine reports that researchers from the Autonomous Technological Institute of Mexico, and who knew we had one of those, have successfully been able to transmit audio, video, and internet at rates up to 10 gigabits per second already. But researcher Harold Haas has taken his technology one step further and is now experimenting with replacing LED lights with laser diodes to achieve beyond 100 gigabits per second. Advancements in Li-Fi technology may just make your next visit to the doctor a wireless affair powered by Li-Fi LED lights. So let's think about that for a second, guys. They can scan via Li-Fi. They can get EEGs and EKGs just by shooting a beam of light from an LED light bulb on you with some sort of signal processor inside of it. That's got to be pretty frightening. This is beyond ubiquitous, and we've lost every bit of privacy. I mean, we thought cameras and microphones were bad, and now they can do brain scans without you even knowing. And I found a story, follow up on that, out of Nature publication. It's where they publish a lot of the science white papers. Brain scans can pinpoint individuals from a crowd. Distinctive patterns of neural connectivity also correlate with intelligence. So not only would we be able to tell who you are, they'll be able to tell whether or not you're good breeding stock in the future by your intelligence. and what genes they want passed down to the next generation of humans, as Patrick Jordan and Clint Richardson had talked about. Our brains are wired in such a distinctive way that an individual can be identified on the basis of brain scan images alone, neuroscientists report. In a study published in Nature Neuroscience on October 12, 2015, researchers studied scans of brain activity of 126 adults who had been asked to perform various cognitive tasks such as memory and language tests. Data was gathered by the Human Connectome Project. Ding, ding, ding. And we talked about that Connectome Project yesterday. That is a multi-organizational project that's been going on for quite a long time. I'm pretty certain that IBM was involved in that as well. And now we have this, talked about it at length yesterday, the Brain Initiative that's backed by the White House, the National Institute of Health, and all the big universities and organizations. We have Paul Allen, co-founder of Microsoft, who's offered to database it all. Yes, that whole Brain Initiative, to be able to crack the secrets of who we are and how to get into our brain. And this Connectome Project, which is a $40 million international effort that aims to map out the highways of neural brain activity in 1,200 people to start. To study connectivity patterns, researchers divided the brain scans into 268 regions or nodes, each about 2 centimeters cubed, comprised of hundreds of millions of neurons, and they looked at areas that showed synchronized activity, rather like discerning which instruments are playing together in a 268-piece orchestra. In some regions of the brain, such as those that involve networks controlling basic vision and motor skills, most people's neural circuitry connect up in similar ways, but patterns of connectivity in other brain regions, such as the frontal lobes, seem to differ between individuals, and that is like the frontal, prefrontal orbital cortex we found out, where they had all the decision-making that was being made. I'm sure we all came about different ways of developing our brain skills, and that would be why they would be individualistic prints. The researchers were able to match the scan of a given individual's brain activity during one imaging session to the same person's brain scan taken at another time, even when that person was engaged in a different task in each session. Guys, how frightening is this? All it takes is one time for them to scan your brain. And if they can scan it again, even if you're doing something completely different, they were able to identify that person. Now tie that into a database, good old Paul Allen, and connect to that some 230-point facial recognition and all the other crap Google's got on you from the internet. And they're going to have a pretty beefy dossier on you. Let's add to that all your 23andMe cheek swabs that you've sent in for your DNA. Or even if maybe you're young enough that you were DNA sampled at birth like they do here in a lot of the states, and add that to the dossier, and they're not going to have any doubt as to who you are and how you tick. Till now, we really didn't know the extent to which each unique individual had a unique pattern of connectivity, says cognitive neuroscientist Russell Poltrack at Stanford University in California. The variations in connectivity patterns also correlate with a person's performance on an intelligence test, say researchers. And that does not mean that a person's smarts can't be deduced from a brain scan, but the uniqueness seems to be tied to cognitive function in some way. In particular, people with stronger connections within and between their prefrontal and parietal lobes, which are usually particularly active when people are performing a demanding cognitive task, scored more highly on the test. These neural fingerprints are not a perfectly reliable signature. The scan of the circuitry of the frontal, parietal, and temporal lobes, for example, taken of a person lying at rest in an MRI on one day, could be used with 98 to 99% accuracy to pick out a brain scan of the same person on another day, but the predictive accuracy dropped to 80 to 90% when that person was performing a different cognitive task during the second session. Now, I thought we read a story. This story is from October 2015. We read a story this year that was a news story that said that they have now jacked that up to 100%, what would you call it, accuracy rating to be able to identify somebody by their brain scan. But even at 80 to 90%, that's pretty scary accuracy for just walking under a light bulb, let's say. Finn thinks that knowledge of an individual's brain circuitry might one day help clinicians to tailor therapies to specific patients. Of course it is. We have hundreds of drugs for treating neuropsychiatric illness, and we're chomping at the bit to use them. And we got good old Tommy Insel, former director of the National Institute of Mental Health, over at Google's Verily now, that wants to find ways to fix your brain. So look out. But there is still a lot of trial and error and failed experiments. This might be another tool. But there is still a lot to learn about how the underlying physical structures of the brain differ from one individual to the next. So step right up. Become a part of that cohort program so you can be one of 1 million that they can put into a database and scan and be able to determine the differences between you and me. So in the future, someday, they can use it to figure out who you are from a distance and what you are thinking. I mean, this is Big Brother on steroids, and they are telling us right now that they have this technology. They need some more people to use in the Petri dish to be able to get better at it. And, it's going to be for your own benefit. So we can find new ways to treat your psychiatric illness. Anyway, Jeff Lichtman at the Harvard University in Cambridge, Massachusetts, has been working on this, and he says, to take the orchestral analogy, researchers may be able to see that drums and violins tend to play together, but no one yet knows why the orchestra plays this way or understands the source of the instructions to play loudly, softly, or not at all. So put on a seatbelt, people. They are already in our heads using LED light bulbs. I don't know. They are completely bastardizing nature and the way it was meant to be used. Light was not meant to scan your brain, though maybe it was on a grand scale. Maybe that's why we can think thoughts and it can be on the other end of a spectrum somewhere. I don't know. I've seen some pretty crazy stuff with quantum entanglement recently, and they've been making some discoveries. And I just saw some scientists created a mini black hole on his desktop using sound, and they think now that they have been able to show quantum entanglement through that as well. So, I don't know, some really weird stuff going on. Physics is getting cracked all over the place, as is neuroscience and biology. And this can't be a good thing. I mean, we have infants, respectively speaking, who are working on this. These are not people with a grand understanding of the universe and how it all works. These are people with theories that are poking with needles around to see what happens when they push this or that. And though they purport to know it all and want you to step right up for these experimental treatments to cure you, quote unquote, these are not, these people that call themselves scientists and doctors come off like they are the authorities of knowledge, but they are just in the dark as we are, maybe a little less in the dark because they kind of have the toys to play with. But these guys are bumping around in the walls to see what sticks and what doesn't. So I would not step up for any of these treatments or be a cohort to feed any more information into the machine, guys. That's what's going to eat us whole, is all this information that we feed in on a daily basis. So, all right. So now talking about mad science, here's one I ran across yesterday. This is out of the Office of Naval Research, and this is one of those secretive locations where they do stuff like DARPA does. But this is within the Navy. Genetically modified soil bacteria can work as electrical wires. What? Yes. Scientists have genetically modified a common soil bacteria to create electrical wires that not only conduct electricity, but they are thousands of times thinner than a human hair. Scientists sponsored by the Office of Naval Research, or ONR for short, have genetically modified a common soil bacteria to create electrical wires that not only conduct electricity, but are thousands of times thinner than a human hair. As electronic devices increasingly touch all facets of people's lives, there is a growing appetite for technology that is smaller, faster, and more mobile and powerful than ever before. So we got light bulbs that can transmit data at super high speeds and do brain scans. And now we got soil bacteria that can be modified to be electrical lines. What? This is just, they're turning the entire planet into something digital. But they're going to morph biology into the middle of it. This should be beyond frightening for everyone. I don't want soil bacteria that can run electricity. Thanks to advances in nanotechnology, which in parentheses, they got to give us a definition, manipulating matter at an atomic or molecular scale, industry can now manufacture materials that are only billionths of a meter in thickness. And these sponsored scientists, led by microbiologist Dr. Derek Lovely at the University of Massachusetts in Amherst, says that their engineered wires can be produced using renewable green energy sources like solar energy, carbon dioxide, or plant waste, and are made of non-toxic natural proteins, and avoid harsh chemical processes typically used to create nanoelectric materials. Research like Dr. Lovely's, Dr. Lovely, sure is lovely, could lead to the development of new electronic materials to meet the increasing demand for smaller, more powerful computing devices, says Dr. Linda Chrisley, a program officer in the Office of Naval Researchers Warfighters Performance Department. Ding, ding, yes, the Warfighter Performance Department is funding this research, so that cannot be good. Who sponsors this research? Being able to produce extremely thin wires with sustainable materials has an enormous potential application for components of electronic devices such as sensors, transistors, and capacitors. Yes, and all better ways to surveil you, my dear. The centerpiece of Lovely's work is the Geobacter, a bacteria that produces microbial nanowires, hair-like protein filaments protruding from the organism, enabling it to make electrical connections with the iron oxides that support its growth in the ground. Now, I was just thinking as I'm reading this, if this is a genetically modified bacteria that lives in the soil where you plant your food, that can produce microbial nanowires that are protein-like, very super thin filaments that protrude from the organism to enable it to make electrical connections, how long is it going to be before something like this ends up in our body? Think about that for a minute. It is a bacteria that can run electricity, that is so tiny, and it will be so prevalent if it can grow in soil. This is beyond dystopian. Although Geobacter, Geobacter, naturally carries enough electricity for its own survival, the current is too weak for human use. But it is enough to be measured with electrodes. At least it's too weak for human use right now. Lovely's team tweaked the bacteria's genetic makeup to replace 2 amino acids naturally present in the wires with tryptophan. Tryptophan that makes you sleepy when you eat turkey, which is blamed, incorrectly some say, for the sleepiness that results from too much turkey. So they're saying that that is incorrect. Well, tryptophan is also a chemical that is very prevalent in the brain. And it's one of those buttons that they can push. Food allegations aside, tryptophan actually is very good at transporting electrons in the nanoscale. As we learn more about how the microbial nanowires worked, we realized that it might be possible to improve on nature's design. And of course, that is what this is all about. They are becoming gods. They are taking what nature created over millions of years and created this beautiful design, and they're bastardizing it into their own image and enslaving it to use for whatever means, nefarious or otherwise, they want. And remember, this is the Office of Naval Researchers Warfighters Performance Department who is funding this research. We rearranged the amino acids to produce a synthetic nanowire that we thought might be more conductive, and we hope that Geobacter might still form nanowires and double its conductivity. The results surpassed the team's expectations, as the synthetic tryptophan-infused nanowires were 2,000 times more conductive than their natural counterparts. And they were more durable and much smaller, with a diameter of 1.5 nanometers, which means that they are 1,000th of a nanowire could possibly be stored in the tiniest of spaces. Lovely and Chrisley both say that these ultra-miniature nanowires have numerous potential applications as electronic and computing devices continue to shrink in size. For example, or they start embedding them in us. For example, they might be installed in medical sensors where their sensitivity to pH changes can monitor heart rates or kidney functions. From a military perspective, these nanowires could feed electrical currents to specifically engineered microbes to create butanol, which is an alternate fuel, and this would be particularly useful in remote locations like Afghanistan, where fuel convoys are often attacked, and it costs hundreds of dollars per gallon to ship fuel to warfighters. And you know, what's really amazing about this is we read all about the Department of Energy's foray into synthetic biology, and that's what it was all about, was to be able to create synthetic organisms, and this was in their synthetic biology report to Congress from 2013, to create organisms that could produce quote-unquote alternative fuels, or, who knows, terraform a planet like Mars, right? We had the woman from DARPA come out and talk all about that in Motherboard, about how we might use some of these GMO bacteria to terraform other planets. But first we were going to experiment on planet Earth with utilizing these synthetic microbes to clean up areas on planet Earth that cannot be cleaned up by humans or any of our current technology. You know, there's been all kinds of questions about what they did to the Gulf. And there were these microbes in the Gulf that they discovered, lo and behold, that were eating all of the oil that got spilled by the BP oil spill. And, you know, they said, oh, we shouldn't have sprayed all that Corexit. But I have a feeling, and, you know, this is just a feeling, but there's been all kinds of rumor out there that maybe that BP oil spill was a big grand experiment, especially when you find out companies like Halliburton were involved on both ends of the game. Not only the drilling of the well, but then the cleanup crew after the fact. They had just purchased an oil cleanup crew right before the BP oil spill happened. So, I don't know, take that for what it is, but it all seemed very, very suspicious to me. Anyway, this is an exciting time. Yes, exciting time to be alive. To be on the cutting edge of creating new types of electronic materials. And let me add to that, electronic materials out of living organisms, guys. They are turning living organisms into drones that then they can utilize for their own means. Lovely's nanowires may also play a crucial role in powering highly sensitive microbes, which could be placed on a silicone chip and attached to unmanned vehicles, that could sense the presence of pollutants, toxic chemicals, or explosives. Yes, they will be biosensors, like we've talked about many times. The fact that we can do this with sustainable, renewable materials makes it even more rewarding, and oh, how wonderful it is, because we're going to sell all this as green technology, just like they're selling the genetically modified mosquitoes that they want to release planet-wide as being a green solution because they're no longer spraying pesticides. No, but you're letting this mutant go into the environment that we have no idea what it's going to do generations down the line to the biology that was here beforehand, created by nature. Lovely's research is part of the Office of Naval Research's efforts into synthetic biology, which creates or re-engineers microbes and other organisms to perform specific tasks like improving health and physical performance. Yeah, I really want synthetic biology that's either created from scratch or re-engineered to be involved in my health or physical performance at all. No, thank you. This field is a top ONR research priority because of its potential far-ranging impact on warfighter performance and fleet capabilities. Yes, the war machine is what it's all about. Let's use stuff that is so tiny, so teeny tiny small that no one will ever be able to battle it. And once we let that genie out of the bottle, there is no putting it back. And, you know, to add insult to injury, again, out of Cambridge, Massachusetts, the Broad Institute. We've read about the Broad Institute with that George Church being involved, and now I don't remember his name, but that guy that's now on that new Department of Defense board with all the tech billionaires, who is another co-founder of the Broad Institute to bring synthetic biology to the board of the DOD. And, well, here's a story. This is September 24th, 2015, so just under a year ago. DARPA, you knew DARPA was involved somewhere here, awards $32 million to contract MIT and the Broad Institute to bolster DNA design and manufacturing. What? Design and manufacturing? Yes, design and manufacturing. And remember, the Broad Institute is connected to the Weiss Institute of Harvard. The Weiss Institute is the Institute for Biologically Inspired Engineering, where our DNA origami robots and the Robo-Bees came out of. A facility at the Broad Institute of MIT and Harvard, and MIT, so I don't know, I guess that's the name, aims to achieve the full potential of engineering biology, and it has received a 5-year, $32 million contract from the Defense Advanced Research Project Agency, more affectionately known as DARPA. The foundry, started by MIT biological engineering professor Christopher Voigt and Broad Technology Labs director Robert Nichol, is the result of a partnership between the Biological Technology Labs and the Synthetic Biology Center of MIT, of which Voigt is co-director. The foundry enables the rapid design, testing, and fabrication of large sequences of genetic information so they can be assembled like building blocks for a myriad of medical, industrial, and agricultural applications. And I'm going to add to that, we got DARPA who's funding this research. I'm going to add to that also war-fighting applications. They don't mention it, but DARPA doesn't do things for our own good, okay? Quote, society relies on many products from the natural world that have intricate material and chemical structures, and from chemicals such as antibiotics to materials like wood, says Voigt. We have been limited in our ability to program living cells to redesign these products. We're literally redesigning life and matter. Okay, understand that. That's why people look at me and they point and they're like, Jewel, man, you're so obsessed over this stuff. But this is real, and this is happening, and it's happening at a molecular level, a level where it's not going to be in your face. There are not going to be commercials about this. This is not going to be in the headline news. Only the end result is going to be. So they're going to have this grand new therapy or this grand new medication, this grand new way to, scan you that'll be sold and spun as a consumeristic product. We read yesterday about those new brain implants. There's a new company out there. I don't remember their name. We covered it yesterday. They're now commercializing brain implants. And they said, how long is it going to be before, this is all done in the name of increasing your brain capacity to make you smarter, Johnny. It's not going to be too long, especially if there's a price tag on it. We are a consumeristic society that runs after that dangling carrot. Be better than the Joneses. So anyway, we have been limited in our ability to program living cells to redesign these products. For example, to program living cells to create materials as intricate as wood or seashells, but with new and better properties. And rather, products from synthetic biology have been limited to small, simple, organic molecules, and I want to change the scale of genetic engineering to access anything biology can do. Now remember, too, George Church, as a part of this broad institute, had that meeting with 150 geneticists at Harvard, the secret meeting, about how to engineer the synthetic human genome. And then they came out shortly thereafter and said, hey, guess what? There's no more ethical quandary anymore about that. We're going to do it. Yep. There's billions of genes and DNA strands to scan for us to figure this out. But guess what? We'll figure it out. Don't worry about it. It's coming. DARPA had their Living Foundries program that we probably covered 3+ years ago. That was already messing around with ATCG to see what kind of organisms they could build. And then they created their BTO, the Biology Technology Office. That was last year, I believe, under DARPA for genetically modified, mad science gone mad organisms. Anyway, the Broad Institute's Nicole, which is one of their scientists, pioneered the application of manufacturing principles to DNA sequencing, and this technology quickly scaled from deciphering a single human genome to examining thousands of organisms, including everything from soil bacteria, just like that soil bacteria we just read about, that the Office of Navy Research, like I said, that's the Navy's DARPA division, has now turned into some sort of genetically modified electrical signal processing. It's absolutely insane. From soil bacteria to elephants. And what elephants? Yeah, didn't we talk about George Church being a part of bringing back the woolly mammoth? And I told you I saw that documentary about their search across Africa to find the perfect elephant DNA candidate to be the, what do they call it, surrogate for birthing this resurrected woolly mammoth. The Foundry is working to realize an analogous revolution in designing and writing DNA, in which instructions for useful biological functions are converted into physical DNA that then can be put into living cells. This effort will be supported by DARPA funding derived from where? Oh, here we go. The agency's Living Foundries. It's called Living Foundries 1,000 Molecules Program, which seeks to establish facilities that could rapidly engineer cells and make chemicals and materials not found in nature. And that DARPA woman in that Motherboard article talking about terraforming Mars and synthetic biology had said that in the future, their whole plan is to be able to push a button and create a life form on demand. So, guys, I know this sounds frightening, and yes, it is as frightening as it sounds, because that is the grand plan. And it's not even secret. It's just that people don't want to believe it, and so it's not news. It is so beyond believability that people will just give you the look and go, yeah, well, she's a bit nuts. Just don't mind her. Let her drink a beer and babble along about her fantasies. This is no fantasy. The document I'm reading right now is right out of the Broad Institute. Anyway, to create the efficient and innovative pipeline needed to meet this goal, the Foundry, and that is DARPA's Living Foundry's 1,000 Molecules Foundry, collaborates with academic and industry partners. Academic partners include Michael Fischbach, an associate professor at the University of California, San Francisco. Ding! We just came upon him yesterday, who has pioneered methods to find combinations of genes that encode desired functions from vast databases of sequenced information. I wonder if who's making those databases. I'd be interested to see that. The Foundry has also made it possible to do something that used to only be a figment of my imagination. Yes, ding ding, says Fischbach, because combining these genes into a new design requires specifying a precise sequence of millions of DNA nucleotides specified by their ATCG letters, which is a daunting task for an engineer to do by hand. The Foundry also works with Douglas Denmore, a computer-aided design expert in the Department of Electrical and Computer Engineering at Boston University. And after a design is built, determining whether it works is slow due to the time required for DNA to be put into cells and then for them to grow. So, thank goodness it takes some time. But technology from Northwestern University allows newly built designs to be rapidly prototyped in advance of emulsions that mimic the interior cells, cutting the time it would otherwise take for new DNA to be put into cells that must grow. So they got a way now to fast-track all this stuff. The Foundry also interacts with industrial partners through a consortium that seeks to disseminate advances in the foundational tools to design and build DNA. And member companies span industries involving chemical companies, pharmaceutical companies, the food industry, energy, agriculture, and biotechnology. So they're all in on the game. All of them. It's across the board. They represent a diversity of interests. Some hope to generate functionalized textiles with integrated biological properties so your clothes will literally be alive, while others are in search of faster ways to manufacture biofuels and versatile plastics made from green sources rather than from fossil-based ingredients. 2 years ago, with an infusion of $7 million in seed money from DARPA's Living Foundries program, Voigt and his colleagues laid the groundwork for the Foundry, creating a pipeline for swiftly assembling massive genetic systems involving many genes. Yes, this is this whole self-assembling DNA, origami robot, nanobot stuff that they've been working on. And now they have successfully demonstrated the viability of this platform, churning out hundreds of megabases of DNA in a fraction of the time that it would have taken with conventional techniques. Guys, this is the law of accelerating returns that we've been talking about, where now we are using computer-aided simulation and design to be able to churn out hundreds of megabases of DNA to be able to be used where? Oh, in the food industry, in the agriculture industry, biotechnology, energy, pharmaceutical, and chemicals. This is the apocalypse. I hate to say it, but this is the end of biological life on the planet as we know it. This is a bunch of lunatics creating bastardized life, mixing monkey and human. Well, no, they said they weren't going to allow that just yet. Mixing mice and human DNA, or microbial and human DNA, or virus and human DNA, or virus and bacteria. Mix and match. There are no rules. Nobody is watching the henhouse. And this work has led to some significant advances. I don't know how much more of this do we read. This is beyond horrifying. Foundry capabilities are also enabling research in other fields, including medicine. Tapping the Foundry's resources, Voigt has begun to research on how bacteria can naturally reside inside of humans. Yes, ding, 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 just like those electrical ones we just read about. How long is it going to take with their little nano wires to get inside of us and to make us some sort of cyborg? I mean, I don't think that's going to be too long. You know, it's going to be in the name of curing a disease to begin with. But then it's going to be in the name of augmentation later because, you know what, Johnny? It'll make you smarter and stronger and healthier, too. And we'll be able to monitor all of your biostatistics and be able to tell whether or not there's going to be a breakdown in the near future. Voigt has begun to research on how bacteria that naturally resides in humans can make compounds that could be potent new drugs for infections, autoimmune, and neurological diseases. But prior to this work, researchers could only identify the genes that are like encoding pathways to new pharmaceuticals, but they had no way to make use of human bacteria for the use of therapeutics. So there you go, guys. Make sure you look them up. That is the Broad Institute, broadinstitute.org. Make sure you read all about it. Founded by MIT and Harvard and all of their affiliated hospitals, as well as visionaries from the Los Angeles area, philanthropists Eli and Edith Broad. They include faculty, professional staff, and students throughout MIT and Harvard's biomedical research communities and beyond, with 40 countries worldwide working on all of this. So, all right, guys, if you could even believe it, that's an hour gone by. Make sure you stick around because Mr. Kevin Blanche is live up next, and it is Thursday. So we have a new Ocelli Effect at 3 p.m. Eastern. Ron with Game On Live at 7, Behind the Woodshed this week at 8, and Anti-Media Radio with SM Gibson live at 10 p.m. All right, guys, have an awesome Thursday, and I'll catch up with you tomorrow. Everybody take care.
Of the World Economic Forum. We have a tremendous conversation to have this morning with a tremendous group of people to talk about the Fourth Industrial Revolution, which is, of course, the very theme of the entire next several days that we're all going to be talking about, what the Fourth Industrial Revolution means, what the opportunities are, and, of course, what the risks are as well. Let me introduce this panel and try to get to a conversation as quickly as we can. Satya Nadella, of course, the CEO of Microsoft, just made a big announcement, which we're also going to talk about as well this morning. Sheryl Sandberg is here. She is the COO of Facebook, and she made her own announcement in the past 2 days that I want to get to as well. We also have Anand Mahendra here. He's the chairman and managing director of Mahendra & Mahendra of India, and they are doing some very interesting things there when it comes to what this Fourth Industrial Revolution really means. And then Zach Bookman is here. He's the CEO of OpenGov, rather. And he is really changing the dynamics in terms of the political landscape and transparency in the United States. And I want to talk to him about what all of this means to democracy, not just in the U.S., but writ large. Here's where I want to start the conversation. This is Klaus Schwab on this very theme that we are going to be talking about. He says that today I believe we are on the cusp of the Fourth Industrial Revolution, powered by billions of connected devices, 3D printers, and super smart robots, to name just a few. This revolution will not only change entire societies and economies, it stands to transform the very essence of human nature. So are we ready for it? I want to go to Sheryl. You're in the middle. You're our only woman here today, by the way, and we're going to talk about that as well. Tell us two things. What do you see as the opportunity in all of this and what that connectivity brings? And you guys are involved in AI and all sorts of other new technologies. But also, should we fear all of this to some degree?
I'm going to start and answer that question with 3 stories. A woman named Riza in the Philippines. She lived on an island. She was commuting to school by boat. A typhoon hit her island. School was over for her. Because of Free Basics, the program to provide free data to Facebook and other services we provide, she connected to the internet, finished her courses online, and now is gainfully employed. A woman named Pearl in India started a service called My Rights to explain to women like her what their rights were and whether or not they were victims of domestic violence and what were the things they could do to stop it in their own homes. Women who couldn't leave their homes because they were victims of domestic violence were able to get that information in the safety of her own home. A woman named Nima in the DRC realized that women are 25% less likely across the developing world to have access to data and the internet, started cyber cafes for women only. A group of local women started coming. A couple of years later, a couple of them had been not just connected to data and the internet, but elected to local government. Connectivity, data access is too important to keep it only to the world's rich. There are 4 billion people in the world who don't have access. And when they get access, they are more highly educated, they have job opportunities, they have longer, healthier, more productive lives. And importantly, it's not just what they get from us because they can be connected to data. It's what we get from them because we get the benefit of their ideas. I think we're at a really important moment right now, which is the question of whether or not we are going to think about the changes the world is happening in terms of hope or in terms of fear. There's definitely rapid change going on, right? Innovation is always disruptive, and every technology that's ever been invented has caused great fears. And I think the questions that Davos is trying to answer this year are, how scared should we be or how hopeful should we be? Will AI take over for all human intelligence? Will virtual reality mean that Satya and I never have another in-person conversation? Will what people are calling the fourth industrial revolution mean that all the jobs are destroyed? My answer to that is no. AI is being used by Facebook to help blind people understand the pictures on Facebook and therefore be able to connect. Virtual reality is being used at this conference to show a film called Clouds Over Sidra. It tells the story of a 12-year-old refugee girl and what her life is like. And because it's virtual reality, it's really much easier to feel connected to her and have an immersive experience. And while we certainly have major issues that we need to address in terms of jobs that are being destroyed, we also have the possibility of job creation at a scale that's even larger. So I think the answer needs to be the triumph of hope over fear.
Okay, so that's the good news. Satya, let me ask you this. You had an op-ed in the Financial Times, and you made an announcement, which I want to get to in a second. But in that op-ed, you talked about the potential for this creation of the haves and the have-nots when it comes to all of this connectivity and what that ultimately means. I assume you're optimistic.
Oh, absolutely.
But to some degree, are we creating an even greater schism in the world of inequality, if you will, especially, by the way, not just in developing countries, which are actually the beneficiaries of this to some degree, but in developed countries?
Yeah, I mean, I start where Cheryl ended, which is with optimism and hope to what I think the fourth industrial revolution could mean for all of us. The real question I think that we will debate a lot at this forum is going to be, is there a digital dividend or a digital divide? And it's the right debate to have. The thing that I would like to sort of propose is that we all need to strive to create the digital dividend. There is going to be economic surplus that's going to be created because of this fourth industrial revolution. The question is, how evenly will it be spread between countries, between people in different economic strata, and also different parts of the economy? And when you ask that question, I see hope. For example, there's a Kenyan entrepreneur who has figured out how to create, using data, which is the new currency in this fourth industrial revolution, to create a credit rating for people under $2 a day. So that's something that's going to give them more credit, which was not possible in the past. There are researchers in Sweden who are using AI, basically data again, to figure out kids with dyslexia and then figuring out how to intervene in their lives. There are public, governments in Andhra Pradesh in India or in Kentucky in the United States using data again to figure out which students are going to drop out and how to take the scarce state resources and channel it so that those students stay back in school. So I see all of that as essentially using, for example, data or public cloud technology to create public good. That's the theme that led us to make the announcement where we want to make sure that there's cloud technology that's available all over. So we're going to, make it possible for them to get $1 billion. This is NGOs, civic organizations, and researchers, so that they can access the world-class technology, not just to consume it, but to create their own world-class solutions, like the ones I referenced. That's the hope. That's what we want to make sure happens. And I think it'll take all of us and the debate.
I want to turn the conversation a little philosophical for a second. And I want to talk to you about this because we talked about this in the green room just before. Really about humankind and human nature. One of the things that Klaus talked about is how this revolutionizes humankind, how we actually communicate and relate to each other. In this, I think I told you, Klaus Schwab said, the revolution will not only change entire societies and economies, it stands to transform the essence of human nature and our connections because of 3D printing and super smart robots. And that becomes the relationship. What do you make of that?
You know, Andrew, I used to always be puzzled when people would talk about fear of technology and change. Because the evidence is quite to the contrary. Technology has only helped humanity and the quality of life. But a couple of images come to my mind which truly do scare me. And you use the word fear. And scare me for humankind, if you will. One was very recent. I was in New York and I was at dinner with my family. And next to us there were four young girls having some kind of teen get-together. And the moment they sat down, they pulled out their iPhones. And we timed them. For 15 minutes, they didn't say a word to each other. They were just looking at it. And my daughter said, you know what they're doing, Dad? They're Instagramming their friends saying, girls' night out, having a great time. And I thought about that and I said, you know, this will be recorded. So it will go out to multiple phones. And everywhere around the world, maybe somebody will pick it up in India, there were people who had a girls' night out. And I know there never was a girls' night out. It eluded them. The essence of that human interaction is being recorded, but it never existed. It's some kind of ghost world people are talking about. So I was scared. The other thing that happened was, I don't know, many of you must have seen in the past 6 months, there was a video clip that went viral that purported to be about the US Air Force conducting a raid in the Middle East where they were sort of killing their prey. And it was a radar screen. And the prey were in infrared. Somebody's nodding, so you've seen it. And you heard these pilots exulting when they shot someone. And I thought about that, and just a little blip of light on that radar screen was a life being extinguished, but it was like a basketball game that was going on. And it scared the hell out of me. So that, to me, is what I think Klaus is talking about, is the loss of humankind. So there has to be empathy. My point is, what we need is, how do we program not artificial intelligence, but artificial empathy? My point is not that optimism is guaranteed. I'm sorry, I can't resist the temptation of a Star Wars analogy. But you know, the Force is a force that can be misused or used. If it's used for the good, you're a Jedi. If it's used for the bad, you're a Sith, member of the Empire. I think the choice we have to make is, do we want to be Jedis or do we want to be Siths?